Hi everyone, thank you for joining. So in this video we're going to solve an integer equation. We're given that n is greater than or equal to 3 and we have an equation 1 over x1 plus 1 over x2 plus and so on all the way up to 1 over xn, and that's equal to 1, and we want to prove that this equation has solutions in distinct positive integers. In other words, we want x1 not equal to x2 not equal to x3 not equal to xn, right? If you like to pause the video and try it yourself first, then we could go over it together. Okay, so let's use proof by induction. There are several methods, but let's choose proof by induction. So let n is equal to 3, then it's not very difficult to guess that we have 1 over 2 plus 1 over 3 plus 1 over 6 is equal to 1, and 2 is not equal to 3 is not equal to 6. Right? So it is true for n is equal to 3. And then we make an inductive hypothesis. So the assumption is that 1 over x1 plus 1 over x2 plus 1 over xk is equal to 1, where x1 is not equal to x2 is not equal to xk. So this is the assumption, right? Now, without loss of generality, let's since x1, x2, and xk are real numbers, in fact positive integers, we can order them. x1 is less than x2, is less than x3, is less than, and so on. Okay, so let's define x1 dash to be 2, x2 dash to be 2x1, and so on, all the way up to xk plus 1 dash to be 2xk. Okay, so the ordering here still holds because all we did is we just multiplied by 2. So we have x1 dashed is less than x2 dashed is less than x3 dashed and so on, right? So they are distinct positive integers. And if we write 1 over x1 dashed plus 1 over x2 dashed plus 1 over xk plus 1 dashed, that's the same as 1 over 2 plus 1 over 2x1 plus 1 over 2x2 plus all the way up to 1 over 2xk. That's equal to 1 over 2 plus 1 over 2 into 1 over x1 plus 1 over xk. So that's equal to now 1 over 2 plus. Now from the assumption we have this is this to be 1, so we have 1 over 2 or plus 1 over 2, which gives us 1, right? So we have proved that proof by induction that we can always find distinct positive integers such that these summation of these reciprocals will add to 1, right? I hope you enjoyed it. I hope you found it interesting. Thank you very much for joining, and I look forward to seeing you in my future videos. Thank you.